Hi everyone, I'm Sri Padma. I work as a junior DevOps engineer. Today we are going to discuss about the monitoring tools. The monitoring tools we are going to discuss today is Prometheus, Grafana, Loki, and Alert Manager. First of all, why we are using monitoring tools means to monitor the infrastructure which can give us the correct performance metrics about the CPU memory utilization. So first, let us discuss about the Prometheus monitoring tool. So basically, Prometheus is an open source monitoring tool which can be used to retrieve the metrics called CPU, memory from the microservices, and also regarding the node metrics and also overall cluster metrics. It describes the metrics in the form of time series data. So, and also it provides the query language to enable the whatever the resources we need, whatever the metrics we want to check, so we can find the uh, metric in the query language. So in the dashboard, Prometheus dashboard will just go and give the metric, and it will give all the information regarding our metrics data. So it is basically used to monitor overall the metrics of our infrastructure from different services. So basically, in our digit environment, we are using the open source Prometheus Helm chart, and we are customizing it based on our requirements. The key features of this Prometheus is dynamic service discovery. Means whenever we are enabling any new service or whenever we are creating a new service, we need not to mention it in anywhere in the configuration. It just automatically picks the chart and it can able to derive the metrics of the chart. For example, CPU and memory, and how much ingress requests are coming for the services or not. And it also supports flexible querying. As I said earlier, it uses the PromQL language to show the metrics and all the data regarding this one. So we can have the PromQL metrics, so we can easily fetch our metrics, and it is also highly scalable. Prometheus is highly scalable because even though it gives us millions of metrics and thousands of targets, it can works very smoothly and it is scalable. And using Prometheus, we can enable alerting also. So whenever our memory or CPU goes above 80%, we can raise it as an alert, so that we can get an information like our volume is storage is full. So then we take an initiative to increase our volume. And it supports exporters. Basically, why the Prometheus needs exporters means, suppose we have Kafka running in our digit environment. So to check the Kafka lags, whether all the documents have been entering to the DB or not. So to give those information, we can use Prometheus Kafka exporter. It supports multiple exporters. And in the same way, we have SSL, like we have our domains. So to check the SSL certificate domains, we have multiple domains, right, in our digit. So to check those SSL certificate domains, we can have Prometheus black box exporter. And to collect the node metrics, we can have Prometheus node exporter. So by enabling these exporters, we can easily fetch all the details. And one of the backlog for this Prometheus dashboard is sorry, one of the backlog for Prometheus dashboard is it is not user friendly. So whenever we are seeing the metrics, it gives in the form of time series data analysis. So it is not a user friendly dashboard. So you can see the use cases infrastructuring monitoring. So using the Prometheus, we can monitor our infrastructure. So basically, if a node contains many number of pods, so the CPU and memory utilization of the node will be increased. So whenever the node reaches certain limit, we can alter our configuration to increase our one more node. So whenever we get this as an alert, so we immediately take an action to increase the node. In the similar way, whenever the pod or deployment has the memory and CPU requires, if the memory and CPU request has been increased, it will go in crash loop back of state. To avoid such cases, we are using Prometheus. So through that, we can have the metrics monitor. We can monitor the metrics, and whenever it increases particular amount, we take certain steps, either to increase the memory CPU or either to decrease the request, so that it will not crash and it will be maintained in the stable state. And we can monitor the latency, like how much speed, like how much time it is taking to give those information, and everything we can monitor using this Prometheus dashboard. So now this is example of the Prometheus dashboard. Now I'll just show you how the Prometheus dashboard will be there. See, if you can see here, this is the Prometheus dashboard and this is the query. Here you can easily fetch the details, which this is the query, and I am executing. Now I am getting everything related to the limits, like it is called resource limits, nothing but memory limits. So whenever we are giving some pod, some memory limits, so that it will be shown here. So it is shown in the form of bytes. So this is why I said earlier, like it is not an user friendly dashboard. You can see it is giving the container audits for every pod. We are getting the metrics, but it is, they are not in the user friendly manner. So we cannot see how much it is using earlier, now how much it is using. So that's why we are configuring Grafana to visualize it more friendly way. So basically, how we are configuring this Prometheus in our Helm chart. In Digit, we are using open source tools. All the monitoring tools which are used in the Digit are open source. And everything we are using in the monitoring, we are just customizing those resources. So basically, whenever you give this value as true in the Helm chart, so then we are making enabling the Prometheus to be true. So then it will fetch the metrics from all the services and it will show these metrics in this dashboard. And if you want to enable ingress for this, you need to just provide ingress as enable true in this one. See, here the ingress has been enabled as true. Whenever the ingress is enabled true, so we can directly access this dashboard through our domain name. This is the service, Prometheus service information. These are all the values which we can be customized based on our requirements. As of now, we are not customizing anything. We are just using the default one, and it is fetching all the metrics from all the services created in the Kubernetes cluster. And Prometheus is also useful for small scale and large scale deployments also. It is scalable, so it can be used in small scale and large scale deployment also. We can get all the metrics using this dashboard, and this is the query where we can provide the query, and if we execute them, then we get all the metrics. So this is how all the metrics we are fetching and seeing using this dashboard. Now we are facing the issue called the visualization. The dashboard is not clear, not effective for the user to see how much. If you see here, the bytes will be there, so user can't calculate how much MB is there, and what type of amount they need to again calculate this value to get through into see how much percentage it has been uh, me- measured yesterday, now how much it is. They need to maintain a calculation. So to avoid this confusion, we are deploying Grafana. So Grafana basically what it does is it is an visualization tool. So whatever the visualization we are seeing in Prometheus, we can see it in a more familiar manner and more easy way, like we can use bars, graphs, histograms in the Grafana so that we can visualize the data more clearly and more effectively. And it is very useful for our monitoring these metrics. And it also supports Grafana supports different data resources. For example, Prometheus, Loki, Elasticsearch, and everything. All these resources can be useful, can be used as a data source in Grafana. Basically, if you see the visualization features, like if you can create a dynamic dashboard in Grafana, or you can directly use the dashboard which you want from the online, and you just need to pick that id and just need to import that id. It, either way you can use your own dashboard, or else you can pick the id, and you can also create an alerting through Grafana. So whenever the dashboard shows the memory size has been increased to 90%, so then you can easily get an alert called the monitoring service pod has been consumed 90% of the storage, so you need to increase the memory there. So in this way, we can directly configure many data resources, and the dashboards can be user friendly. I will show you how the dashboards will look and how we are configuring the dashboards in our digit environment. And Grafana also supports templating. So we can have the common template, and we can use the variables to describe where should be the data can be stored, like particular resource like memory usage, memory CPU usage, memory limits, memory resources. Like everything needs to be in one dashboard if you want. So we can create a common template, and we can just change the query by using the variables, also dynamic variables. And Grafana supports multiple integrations, like now I said earlier, like we can use the data source as a Prometheus or and Loki, and also Elasticsearch, and these are can be used, and many integrations it supports. And also it can be, we can like we can provide authentication to this, like whoever wants to access this one, we can make it as a private one, and we can only access this dashboard using the username and password authentication, basic authentication methods. And the visualization options, like it show, we can monitor the Grafana using tables like heat maps, and also called bar graphs and histograms. We can use all these bar graphs in our Grafana dashboards, so that we can visualize the data more clearly and more effectively. Now let's show the configuration of the Grafana. If you see here, this is our Grafana dashboard. And if you go and check the dashboards, here we have already configured one folder. So in this you can find, this is overall cluster namespace. Like it depends on the overall cluster level, how much it is coming. See, if you can see here, the data source is picking from the Prometheus, and the cluster is none. Like we can, this is the only single cluster. If we have multiple clusters, and it will create one cluster name. Like if we have some UAT, dev, and QA, we can configure it here. So currently I'm using only a single cluster, so it is showing none. And if you can see the whole overall cluster level CPU usage percentage, and overall cluster RAM percentage, like how much the memory has been used and how much CPU has been used. And in my cluster there are 3 nodes present in there, and there are 7 namespaces. And in that namespace, in that node, 73 pods are running. This is the information about whole cluster. So by using this dashboard, we can clearly say how many nodes are present in that, and how many pods are present in that, how much memory a cluster has been using, how much CPU a cluster has been using, and everything data we can say using this monitoring dashboards itself. So the DevOps person will find it very easy to monitor, and so they can provide more reliability and security to the resources. You can see how many secrets are there, how many secrets, containers, running pods, and everything. It will give the information about them. And the cluster level CPU usage, we can see this according to the time series. And we can also customize this one to last 3 hours. So we can customize here the time, like particular, we can give the customized time, or we can use these timelines. And refreshment seconds, like after 30 seconds, every 30 seconds we are refreshing this dashboard so that we can clearly monitor the resources. It can be also customized. So it is a label configuration, and everything can be labeled in Grafana so that we can easily fetch the data. Grafana is not only useful for the technical people, it is also useful for the non-technical people who can be able to see the resources, like how much data has been storing, how many nodes are present, what type of resources are using, how much memory. Even the non-technical people will be able to see this service is using this much of percentage of memory. This is by namespace level. This is the CPU utilization of monitoring namespace and backbone namespace, ego namespace. And it is showing the units of what units the CPU is present, like 0.06 cores, 0.08 cores. It is showing the units also, like in what way this one. You can customize this also if you don't want to see in cores. If you want to see in milli-cores, you can customize that also. Like where you can customize means, if you go to here, if you edit, and you can see the query, right? You can custom, if you customize this query, you can able to see whatever you want to see the metrics in your dashboard. In this way we can edit the dashboard, and also we can customize our dashboards. These are all the dashboards which I have picked from online itself. So if you want to create your own dashboard, you can go ahead and create your own dashboard. I'll show you how you can, after creating the dashboard, how you can configure in our digit environment also. This is the memory utilization by namespace, and it is memory utilization by each node. How much memory has been utilizing each node. This instance is using almost 7.8 GB of memory, and this has been using 7 GB, near to 6.9 GB. So, by seeing this information, we can get a clarity, like at what time we need to increase the memory and what time we need to decrease the memory. So, if we are able to know all the infrastructure metric details by hand, we can automate this process. Like if we are taking an EC2 instances, like if suppose if you are using a dev or UAT environments, based on this metrics data, you can see, okay, at this particular amount of time the traffic is high and the memory utilization is more. So when the memory utilization is more, we are going to increase this node so that the services all can be handled very well, and they all can be in the stable state. If they are not been handled properly, the pods will be in crash loop back off, and all the services will face the downtime. To avoid such scenarios, it is mandatory to monitor all the infrastructure. This is overall the cluster level dashboard, and this is the namespace level dashboard. Like per each namespace, how much it is creating. This is only related to backbone namespace. Basically, backbone namespaces contain most of our core components, like Elasticsearch, Kafka, and Cert Manager. These type of resources have been deployed in the backbone namespace. And this is the resources count, how many secrets are present, how many pods, services, and everything. Each pod, I said to you, right, in the backbone namespace, Elasticsearch and Kibana, Grafan, Agar, Kafka, Postgres, and all these pods have been deployed. So it is showing the CPU usage of each pod. As you can see, afternoon 2:20, the pod usage is more, and later that it is decreasing. So whenever the ingress requests are more, so we'll take certain precautions. Okay, particular time the ingress requests are coming more, so we have to increase the uh, storage size of our pod. So memory size, resources, we if we increase at that time, so the pod will not be in crash loop back of state. In this way, we are taking certain measures, and we are configuring, we are creating the infrastructure to handle the environment in a very proper manner. It is very mandatory to monitor all these resources, and we have to make sure of the every infrastructure metrics, so that the pods will not be in down state, the services should not be down. And if you see the memory usage of the each pod, the Elasticsearch pod has been consuming maximum of 1.5 GB nearly. So whenever we are giving, this is the dev environment. So in the dev environment, the Elasticsearch pod is consuming maximum of 1.5 GB in a day. So in the production environment, we'll just increase it to 3, because there the traffic and incoming requests will be more. So in this way, we'll configure the environment infrastructure, and also we'll use it for the production environment to run in a stable way. And there are no evicted pods, no affinity pods, no we didn't have any unexpected behaviors as of now. So that's why we don't have any data regarding as this much. And what is the status of the pods, like how many are in waiting state, how many are in restart states, how many are terminated, and how many are in ready state, and how many are in running state. And all these statuses we can see using this dashboard. And the persistent volumes, if you can see, this is the persistent volume of the Kafka. So it is also mandatory for whichever the stateful sets we are configuring, in this case, Elasticsearch and Kafka. So every stateful set has a persistent volume attached to that pod. So it is very, we have to make sure that the storage should not be filled. If the storage is filled, the data will not persist in the DB. And then the pods, the data whichever we are pushing through the applications, it will not be persist, and will face an issue called Kafka lag, like the data has been not been consumed. So it is very mandatory to make sure of the storage should not be filled. We have to always monitor the storage volume, and then whenever it is necessary, we need to delete the logs, or else we have to increase the storage size. This is the persistent volume capacity usage for each pod. This is in the percentage way, and this is the bytes. This is in the bytes form, how many bytes it is using. And in the nodes level, what are the persistent volumes present. And this is namespace dashboards, and this is the node level dashboard. If you can see here, we can change the nodes, and we can see here how many pods are running in this particular node. What are the pods running in this particular node? We can see that here 20 pods are running, and these are the 20 pods names which are running in the particular instance, and the particular node CPU level, and the memory level, and the pod wise CPU level, and the pod wise memory, and the system load, context switches and interrupts, like how many times the context has been changed, and the path and everything. The network of the in node, how much network, I means how much traffic has been happening in this particular node. All these things we can monitor using these dashboards. We can configure these dashboards, or we can create dynamically also. And this is the ingress dashboard, like how many requests and traffics are coming for each pod. Here we can configure like ego namespace ingress, like if suppose I want for ego localization. I'm giving this, and here I can see the http requests, status codes, total http requests, and everything, and all the things citation connections. 5 connections are made for citizen, 100% success rate. And these are latencies, how much faster the information is picking from the, whenever we are hitting the domain, how much fast the information has been fetching. This can be measured to the latency and throughput. And the connections in the form of histogram, bar graph, CPU level, percentage of success, and as of now, everything is in success rate. So we are not getting any errors in this dashboard. So whenever we are having any error in the, whenever this pod has been crashing, we can see the errors also. So in this way, we are configuring the dashboards and we are monitoring it through Grafana. And also one more thing, how we are configuring this Grafana dashboard in our environment. We are also using the open source Grafana tool, and in this we are customizing based on our requirements. As you can see here, the dashboard providers. Here the Grafana dashboard Kubernetes we are providing. So from this it will fetch whatever the Grafana dashboard Kubernetes provides contains, it will show in the dashboard level. Here in this Grafana dashboard Kubernetes configurations, if you see, I have provided all these URLs. So only these dashboards are you are able to see in this Grafana dashboard also. As you can see, okay, it's global, and this one is also global Kubernetes. Namespaces, nodes, pods, ingress dashboard. Namespaces, nodes, pods, ingress dashboard, and Loki. As you can here in the values.yaml itself, in the dashboards level we can configure. And if suppose if you are created any dynamic dashboard, so I have created this loki.json as a dynamic dashboard. So how I am giving is, here I have configured this dashboard in my configs repository. I'll go and show. In the configs repository, monitoring dashboards folder. If you can see here, I have created my dynamic dashboard, and from this I am picking the dashboard in the Grafana. Here I am giving the URL of the dashboard. JSON file. So in this way, we can configure our own dynamic dashboard and we can provide it in the dashboards and we can view the dashboard in the Grafana. And also these dashboards are have been stored in this path and this is persistent. Even if somebody deletes the dashboard from the um, Grafana domain, it will not be deleted. Once if we again redeploy the Grafana, it will show all the dashboard also. So if you want to delete any dashboard, we can directly come to this file and we just need to remove this one of the dashboards and redeploy it so that the dashboard will be deleted permanently from the Grafana. And these are all the custom things only. We just whatever we need to enable those values, we can enable using create true or enabled true. Whatever we need to uh, provide, whatever the services we need to provide. If you want to enable any particular things according to your requirement to the specifications of your cluster, we can directly enable it. And this is the helm file, and these all things have been provided in the digi 2.9 lts branch of digit devops repository present in the e-government's organization github account. So you can directly go and check the configuration from there also. You can easily find whatever the resources you need to deploy and whatever the things you need to create, you can easily find there. And this is an open source directly we are fetching this from the repository only, we are just only customizing these values. And here one more thing I need to explain in this dashboard level is data sources. So if we have multiple data sources, we can directly provide here. So the Grafana will automatically fetch the data sources from here only. I am currently providing the Prometheus as one data source and Loki as my another data source because I'm configuring the dashboards based on using these two metrics data only. So I'm providing one data source as Prometheus and the another one as the Loki. Okay, in this way, we are configuring the Grafana dashboard and we are seeing the metrics data information and the ingress level resource request information. If you want to add any other dashboards, feel free to add the dashboards and explore it. And the next one, and this is the example of the Grafana dashboard. And the next one is Loki. Loki is basically used for log aggregation. Like if suppose if we have multiple resources, so we need to check the logs. So every time we can't go to each pod and see the take the cube config file and open the each service logs, and it will be a long process for us to do it manually. So whenever we configure if we want, the Loki will fetch all the log metrics data and it will show it using Grafana. So we just need to only label whatever the pod we want and we can see the log. And also Loki can be directly connected to Alert Manager. So whenever in any services the log metrics have been like if we have the logs, we have three types of logs like info logs, warning logs, and the error logs. If we are getting any warning or error messages in the logs, it will directly raise an alert to our Slack or our mail, whatever we have configured in our alert manager, so that we can easily we can easily check what is wrong happening with the services. So it is similar to Prometheus only. Prometheus collects all the metrics of the data in time series and it collects all the log metrics data. And the Loki uses LogQL language similar to Prometheus. Prometheus uses PromQL language and Loki uses LongQL language. So to query the log metrics in the more complex whatever the more complexity present in the to fetch the logs, so it will be easier using this LogQL language. And using this Logi, we can monitoring the logs. So what are the logs logs coming in each services we can easily find out. And also security and compliance means whenever the logs showing some error or warning, we can immediately raise an alert to that, and we can send it to particular person, so who can be able to resolve this issue. Is it, if it is a developer issue, and we will send to the developers team. As it is an infra related issue, and we can send it to the DevOps team. And the operational intelligence, and Loki is also one such an effective tool. It will store all the logs data in very with many minimal infrastructure. We don't need extra infrastructure also for storing large amount of logs. And the next one is futures label based indexing. And Loki, using Loki we can fetch the metrics, and we can use labeling also for like particular resources. If you want only logs of a particular resources, we can label those resources, and using those label we can fetch the logs. Local query language, I said how it in the backend it will fetch the logs whenever we are providing the information of this particular log data. Like I want only logs of particular services, then it will fetch. We are just giving only the pod name and the namespace. So in the backend it will fetch the uh, colloquial language, and it will fetch the metrics of the logs of the services. Log stream compression, as I said earlier, it minimizes the storage with the minimal infrastructure, and also it stores large amount of log metrics data with minimal infrastructure. And Loki is also scalable. It is used for uh, to Loki is scalable because we, even though if we deploy in the small scale also large scale, it will be effectively, it will effectively work, and it will show all the log metrics data. Even it is useful in small scale deployment and large scale deployment. Even if we have thousands of logs data, it will ease our deployment, and it will show without any error the log metrics data. And Loki is also very useful when coming to integration with the Grafana. We can integrate the Loki as a data source, as I shown earlier in the Grafana chart. We can directly configure the Loki data resource, and we can easily fetch the details of our particular pod, whatever we need. And this is the dashboard, Loki dashboard example. As you can see here in the explore, here the resource is Loki, and is also Prometheus, and now we are fetching the Loki log data. So that's why I'm using Loki. And here label filtering is the label indexing. So I want the container value, and I want citizen pod, and I am providing here namespace, and it is ego. Now if I run this query, log query, and it will show all the logs. As you can see, I'm getting all the logs of my our citizen pod. See, for the digit UI, we can see the logs. If you see how much logs volumes are present for according to the each time period, and also what are the logs of this one. These are the last 30 minutes logs of our digit UI pod. So the developers need not to worry about how to see the logs, and every time they need not to export their kube config and fetch the logs. They can directly view the logs from this dashboard, and whenever they are facing any error in the dashboard, so they'll just go and check what is the issue. Like we can check all these things for all the levels, like app, container, file, job, node name, pod. Like we can check the node level or else pod level, and also using the job level also. Like if we can give the particular job, and we can search also. Like Loki is a new dashboard which we are creating for digit from digit 2.9 9 alias. Earlier we used to deploy fluent bit. Now we have shifted to Loki because it is giving more accurate results of the log search query, and the developers finding it very easy to deploy and also use it. These are all the metrics retrieving from the Loki pod. And this is the example of the Loki dashboard. And earlier we discussed the Loki configuration and how we are going to fetch the logs data using the labeling. And the next topic we are going to discuss is the alert manager. So basically, what the alert manager will do means, and the next topic we are going to discuss is alert manager. Alert manager basically configure with Prometheus, and it will handle the alerts. Suppose if we consider the persistent volume of our Kafka has been filled to 90%. So the after that the data won't be persisted in the DB. So when that issue comes, we can't suddenly go and check every time how much data has been there, how much the space has been left in the persistent storage. So we'll monitor the metrics using the Prometheus, and whenever the volume has been filled up to 80%, we'll raise a warning through the Slack or through the mail or any webhook. Alert Manager provides us the various notification integrations for us. For example, we can use Slack QPI or webhook URL and also Gmail. So in this way, we can configure the Prometheus and Alert Manager so in a better way to monitor our resources. So it is basically used for incident response. Suppose if something has environment has been down, so some pods, all the pods are in crashed due to some reasons. So whenever it can to take the immediate action, we need an alert. So the alert can be configured using this alert manager, and the data can be fetched from the Prometheus, and through the Prometheus it will monitor the metrics, and whenever it fills certain level, so it will send an alert to an alert manager, and alert manager will send that alert to our Slack channel or else our mails. We can configure, and also alert manager doesn't allow the duplicate alerts. It will group the alerts, and it will only send the alerts which are not duplicate. And we can also wait for the alerts to be like whenever the pod is in crash to back off, it will raise an alert, and we can customize it. After when the pod has been in running state, we can again raise an alert showing that no, now the pod has been in running state, everything is fixed. And we can also customize our alerts using groups, like we can only send the alerts to only particular people, and they also can silent those alerts. So basically if we are using in the office timing, so basically we'll monitor all the resources. If we are going to somewhere outside, so then we need the alerts to be shown in our mobile app or in our Slack channel. So in a certain level, we don't need the alerts in the office environment, so we can just silent those alerts at particular times, and after that we can again configure those alerts. And it will also be useful to service level monitoring, because if the service contains some error, and so then it will automatically raises an alert. If it is an OAM killed, like the memory is not sufficient for the pod, so it will be in the OAM killed state. So then it will raise an alert. So the alerts can be configured. Whatever the alerts we want to raise, only those alerts can be configured. By default, there will be many alerts. We are configuring the alerts in the Prometheus one rules, and in that we can customize the alerts. What are the major issues we will face in our digit environment. One, OAM killed. The particular resources should not have the efficient resources. And the next, persistent volume storage is in there. And the crash loop backup state. Whenever the service is in down state due to some build issue or anything else, then the service will be in the down state and will automatically want someone to raise an alert so that we can know that the service is in down state. And the alert manager can also be auto configured these resources, like we can, if we have some regular error coming multiple times, so every time we should not want to fix it. So whenever this alert has been raised, so we can automate that how to resolve this issue, so that whenever the alert has been raised, so the automation script whatever we have been given, it will automatically take the alert, and it will uh, cre- uh, provide the solution, like it will do the solution, and then again it will come back in the normal state. So we can automate these alerts, like whenever the alert has been raised, this is the precaution we needs to be taken, and now this script should be run, so that the whatever the pod or something is in crash loop back or state, it will again become the running state. And the key features of this alert manager is, it I already said, it doesn't allow duplications, and it will also have various notification integration options like Slack, Webhook, and Gmail. And it also has customizable routing rules, how the alerting rules should be configured, like what are the template way, like it should be there for our alert. Suppose if we are raising one alert, I need to see for which pod it is raising an alert, and which namespace the pod has been present, and also what is the error. These three are the mandatory things. So if you want any other details regarding the alert, we can customize the rules. And also alert manager is also highly scalable tool, because even though with thousands of alerts coming, it will seamlessly provide us the alerts, and it will not crash or anything else. It will automatically scale the pods count whenever it has been, whenever the alert has been maximum. This is the sample dashboard. Now I will show the dashboard which we have configured. This is the example of the alerts, how we can configure, like what if you are seeing this, the alert as a Kubernetes pod is not healthy, and what is the pod name, Carpenter pod, and the namespace is in place. These details can be configured according to our requirements, and the alert status also. If it is critical warning, it will show. If we can configure what are the alerts should be critical, what are the alerts should be warning level messages, and what are the needs to be thrown as an immediate manner, like it should be resolved immediately. So you can see all the metrics has been given, and these are the details coming from the alerts. So I have configured in such a manner, it should only show the alert and the pod name and the namespace. So where I'm configuring these alerts means, in this I am using the open source alert manager tool, and I'm customizing my values.yaml. In this alert manager values.yaml, there is certain field called config, and where you can enable this as a tool, and you can provide our customized configuration. So here I want to add send these alerts to the Slack, and you can also use the alert manager to send the alerts to the Gmail also. Here I'm only providing my Slack, and only I'm providing alerts which are critical and also in the warning state. And here if you see, we can also provide the uh, email notification also. Here the receiver match critical continue, even if it is a critical, you can continue to throw the alert. So in this way we are configuring this Slack and email notification. And how this Slack and email notification messages are configured, see here, I'm giving the Slack notification as my name, and here in the channel what are the details needs to be provided, title of the alert, and the next alert name should be there, and the details should be alert name, pod name, and the namespace. The whatever we have configured here has been taken from this template, like whatever it is fetching the is details, right? Here I have provided this configuration. Whenever an alert has been sending to the Slack, it should show the alert name, pod name, and the namespace name. Okay. And in the similar way, we can also have to create the email notification also. So to whoever we wants to send these alerts, we need to add them in the two, and from which email ID the alert should be sent. We have to add that email ID, and we have to give that email ID as an username, and the SMTP password we need to generate it, and we need to provide it here. So then whenever the alert has been raised, it will automatically send to your email. This is the configuration we needs to be added in the alert manager to get alerts to our Slack or else to the Gmail account. And the next one, how this Prometheus, the alerts will be picked from Prometheus means in the Prometheus also in values.yaml, there is a configuration called alerting endpoints. So here we are providing the alert alert manager service name and the namespace and the port number. So it will be taken as an endpoint URL. So the Prometheus fetch this service endpoint metrics, and it will send an alert to our Slack or else Gmail. And how, what are the alerts needs to be generated. So whatever, like whenever the pod status has been filled to the 90%, or whenever the pod has been in crash loop back of state, these rules have been present in the rules. See, here in this alert manager rules, I am configuring my alerts. What are the alerts needs to be sent to the Slack and Gmail? Here I have been configuring these rules. SSL certificate expiring soon. If the SSL certificate is going to expire, we need to raise an alert before 20 days. So in 20 days, after 20 days, the SSL certificate will be SSL certificate is not present. So you need to generate renew your certificate. Has been that expiry has been completing in 20 days. So when the pods are in pending state and the pod is in crash loop backup state, and when the nodes are in not in ready state, and these are all the rules which we are providing so that we can monitor the services, and the services will run without any uh, issue. Like whenever there is an issue, we can take an immediate action and we can resolve this issue based on these alerts, and it will provide us more reliability also. You can see here pod crash loop, pod not healthy, whatever the alerts which we are getting in this Slack channel has been configured in these rules. So whatever the alerts which we want to monitor and on are our priority, so we can give that rules in our alert manager rules configuration, and the Prometheus will connect to the alert manager. Whenever the alert has been raised, it will send an alert to the Slack or else Gmail. So in this way, we are configuring this alert manager. And this is the final architecture of our monitoring tools. And when we are deploying Prometheus, Alert Manager, Loki, and Grafana. The Prometheus and Loki are fetching the information from the microservices or else nodes, and all the services levels. The Loki will fetch the log metrics data, and the Prometheus will fetch ingress request data and the node metrics data. And if you are deploying Prometheus Kafka exporter, it will fetch the Kafka related lags and all those things. And if you are exporting any Prometheus black box exporter, then it will fetch the all the SSL certificate expiry details. So in this way, Prometheus and Loki fetch the metrics from the pods, and it will be visualizing through Grafana, and we are raising an alert from using, you can using Prometheus we can directly raise an alert, and using Loki we can directly raise an alert, and using Grafana we can directly raise an alert. So in this way we are configuring the environment, and through the ingress we are accessing these dashboards. Prometheus can be accessed through Ingress. Loki also can be accessed. Grafana can be also accessed, and Alert Manager also can be accessed through the Ingress. So then after that we are getting some certain alerts. We are trying to take an immediate action so that the service should not be in down state for the long period of time. In this way we are configuring the monitoring structure to effectively maintain the reliability and security of our services. So I hope you understand how the monitoring services have been deployed in our digit and how we are configuring these monitoring tools in digit environment. Thank you.